Okay, hi, we're Team Outliers, and this is the our first project progress demo. And as you can see from this picture, which is the progress that we planned out to do. And for this first video, we're gonna show you how we collected our data and write it to our database. And now Raj will explain the code we use to write the date to get the data and then write it to the database.
So this code session has two code. One is start.py and other one is end.py. In start.py, uh, we collect the data set for GPS, audio, as well as the frames. I mean the photo pictures. So we start with ThinkSport URL declaration, and we try to get the time zone for each recording session. I mean, like for each recording, it creates a unique session ID, which followed by year, month, date, hours, minutes, and seconds. So it's unique for every session. So each session we can record n times videos, and we can capture n into two times photos, as well as like n times GPS recorded. As you see, like following the thing, we are storing the session ID dot text temporarily for the posting purpose in Amazon S3 bucket. And this is a simple code to retrieve the GPS so that we can easily get latitude and longitude. And this is the code to post the data into ThinkSport IO. Hope you will see all the implementation in the video. This is the data we can post in ThinkSport.io, and we are posting timestamp, latitude, longitude, as well as session ID. The session ID, because like we want to get the exact point, I mean exact place of the recordings, so that it's very easy for us to train a model in future. And this function uses a capture photo. We are using the termx command, termx hyphen camera hyphen photo to capture the photo, and another termx command to record the audio, termx underscore microphone underscore record, and it's like has the infinite record capability. So we have to stop by using the termx hyphen microphone hyphen record space hyphen q to stop the sessions. So once the main function started, we run everything in the parallel thread. So we start collecting the location, and when it's like it will like everything runs in a parallelly. So it's started collecting audio. It will also capture the video and everything. After these things happen, and the program will continuously run until the keyboard interrupt. So to stop the program, we need to press like any keyboard interrupt. Usually we do Control C to stop the program. And once the program is stopped, we have to enter the another termx command to stop the audio, because it's like the termx considered as a separate call function. So we have to stop the audio separately. Once we stop the audio, we can just go to end.py. Awesome. So in end.py, we are posting the whole record session. So how the session will be look like? The session folder has an audio file as well as the photo folder, and the photo folder has the picture with same unique session ID in that, with the photo 1 and 2, etc. So we are using Amazon S3 to store the data, because like we plan to use a SageMaker jobs to run our model. So it's very easy for us to integrate the data, or for even for training purpose. So we get the session ID, and that only like the temporary session ID to export the data to S3. And we are using Boto3 is a like Python library which we use to connect to Amazon service. and we are using like access key and access, secret key, or I store it as environment variable. And once the session ID is retrieved, everything is zipped up, and the zipped up folder is sent to S3. And I already declared the bucket name as DSCI 560, so it will be stored in the bucket, as well as in that bucket there is a subfolder called session, so it will be stored in session subfolder. Once everything over, this temporary file session id.txt will be deleted automatically. So I will like to share my screen and to show this recorded session and how those sessions will look like. Okay. So this is our Amazon S3 bucket. As you see, we recorded multiple sessions. So 18th, like, or we recorded on 18th, we recorded on 17th, etc. for this progress. So when you click inside and see, like, here we can just download this, and yeah. So it has the audio as well as it has the video and the photos in that. We can also see that library recordings as well as TJ recordings also, I guess. Awesome. So each recordings has like this photo. We recorded the audio for 45 seconds exactly to for the in-depth analysis of the audio. Can see like multiple photos will be recorded, and each, like, the whole thing has 45 seconds, so we can easily see the 3 seconds audio. So yeah, this is the timestamp of the audio. So this photo is recorded 0 second, and this is recorded start recording from 45th second. So 0 to 45th second, we are focusing on this frame to identify like where's the sound coming from. The reason for using the frame directly is, anyway, we are going to process the video. So we want to like stabilize and predict the efficient output. Anyways, we are not going to use for those videos to predict the population or the crowd. We are only focused on audio. And you will see all the implementation right back.
Now I will be going over our current progress for data collection. So with our ThinkSport.io setup completed and integrated with the Python scripts that we created, we successfully collected data from Android sensors, including GPS, audio, and frames, and transmitted it to ThinkSport.io. The collected data is then stored in AWS S3 for further use, where we plan to implement machine learning models to analyze audio and frames. Over the past week, we have focused on the data collection efforts. And to gather the data, we visited various locations on and near campus, including Levy Library. At the library, we collected data across multiple floors, capturing audio and frames from different angles and positions. Data were recorded every 45 seconds, with the directions and locations adjusted after each interval to ensure diversity in the dataset. And using audio analysis techniques, we aim to extract relevant sounds, filter out noise, and estimate the amount of crowd size based on the processed audio and frames, which will be what we will be working on for the following weeks.
Yes, right now they are recording on the top floor of the library, and you are seeing there are sending data signals which contains the latitude, longitude, and the session ID, what session they are going, and as well as the timestamp. And once every session completed, it will be stored as a zip file in S3 bucket.